problem number 9, we're in radical functions now. Right? So our problems are saying solve each radical function, and in big bold letters they're asking us to remember that there could be extraneous solutions, so we have to go back and check our answers and make sure that when we find a solution that it does actually make sense for our original problem. So let's start off with letter A. Okay, letter A is asking us to solve a function. I'm seeing this little index of 3, which remember this means cube rooting instead of square rooting. And so the object for all of these problems is going to be to isolate the radical function, which means this 3 is going to go, and this minus 4 is going to go, and this minus 4 is going to go, right? And so you're going to have to do whatever operation you have to do to get rid of that. So in this case, this is 3 times the function, so I'm going to use division, and I'm going to turn it into the cube root of 5x minus 1 is equal to 4. To get rid of cube rooting, we do the opposite operation, which is cubing. So I'm going to cube this side, and also cube the right. And so now it says 5x minus 1, because the cube root and the cube will cancel. And 4 cubed is 64. Okay, and now I just keep solving. I'm going to add 1 to both sides, get that 5x equals 65, right? And that means that x is equal to 13. Okay? If I go back and check this, I'm not going to actually go through the steps of doing that, but it does in fact work when you plug in 13 and cube root it and multiply it by 3. You do get 12. So this one is going to check out if you do plug it in. You will not get any extraneous answers. Okay, so letter B, same thing. I'm going to isolate the square root by adding the 4 over. So it'll say the square root of x minus 2 is equal to, well, negative 5 plus 4 would be negative 1. Okay, now I got to get rid of a square root, and its opposite is squaring. And so I need to square the left-hand side and square the right-hand side. And so this is where we have to be careful. Okay. The square root of x minus 2 squared, the square root and the squared will cancel and just leave behind the x minus 2. This, remember, means x minus 1 times x minus 1. So please don't just square both of those parts. Actually multiply it all out and you will get x squared minus 2x plus 1. Right? And now I'm seeing a quadratic function. This is something that I'm going to have to solve by setting it equal to 0. So I'm going to take these two items on the left-hand side and subtract them over. So it's 0 equals x squared minus 3x. I'm sorry, I'm going to add the 2 over plus 3. And so this is where I'm at right now. Okay. So in this case, if I'm trying to find an answer to this, if you try to find something that multiplies to 3 that adds to negative 3, it doesn't exist. We can't actually solve that. So we're going to have to use the quadratic formula. So I'm going to go over here and I'm going to say 3 plus or minus, okay, the square root of negative 3 squared is 9 minus 4 times 1 times 3, okay? All over 2 times 1, okay? So if I simplify inside of this radical, it looks like it's going to say 9 minus 12. Well, if I do 4 times 1 times 3, I get 12. 9 minus 12 is negative 3. So this is 3 plus or minus the square root of negative 3 all over 2. So this is... for our purposes, we're going to say there are no real number solutions. Okay? But if we want to just see this being simplified, I'm going to say 3 plus or minus I root 3 over 2. Right? So obviously, if you go and plug those back in, the left-hand side and the right-hand side are not going to work out because we have I in our problem. Right? But so we can get an I solution. We'll just say, but for our purposes, no real number solutions to our problem. And that's okay. That's going to happen sometimes when we try to solve problems that look like this. Okay? So let's take a look at problem number 10. Okay, I'm not going to do letter C. Letter C and letter B are pretty much exactly the same, right? So just make sure you can solve letter C as well. Okay, problem number 10. It says, suppose you were to write a function p of x that is obtained by transforming this function using these transformations. So we're going to start at r of x, and our job is to apply a right-hand shift by 4, an up by 6, and a reflection over the x-axis. So just to remind you about transformations in general, they look like this. A x minus, well, I'm missing my b value. Let me go put that back. Okay, b times x minus c, okay, plus d, right? And so in our case, the right is going to be a c, right? So this is my right move, okay? My reflection is going to be a, okay? Ooh, that's right, okay? This is my reflect, okay? And my d value is going to deal with the, in this case, up. So right and left, up and down reflections, right? So I'm going to say, make it negative 1, right? That will do the reflection, okay, for A. no b value, but instead of me putting parentheses around b and c, my function was not parentheses, it was square rooting. So I'm going to open up my square root and make sure that b and c end up inside of the square root. So I'm going to say no b value, so that's not going to show up. It's going to be x, I'll move to the right, is just going to be minus 4, right? So this would move it to the right by 4, okay? And then to move up by 6, I'm going to put on the outside plus 6. So in this case, our p of x equals, and again, we can write this a little bit nicer, p of x equals just a negative symbol, right? We don't have to put negative 1. But I would say this function represents starting with my parent function square root of x and applying these transformations using what we know about a, b, c, and d from transformations, okay? Problem number 11, we're now starting exponential and logs. It says round your answer to the nearest hundredth, right? So we're going to need our calculator for some of this. So this says find all solutions. So to remind you about solving with ln or logs, you have two possible answers, and I'm actually going to jump to 13. We'll do 12 and 14 separate. Okay. Problem number 11, it says ln. On the right-hand side, it also says ln. Compare that to problem number 13. It says log, which remember ln is just a type of log. Okay. But on the right-hand side, I don't have another log. Right. Up here, I had another ln, but over here, I don't. So we're going to actually handle these problems slightly differently using two different ways of solving logs. So the first possibility is, well, first of all, let's combine these two ln's together. And so if you remember, the property said if there's a plus sign in between logs, which remember ln's are logs, multiply together what's inside of the logs, and then you're allowed to combine them into one. So I'm going to say this is the ln of, when I multiply these together, I get x squared plus 5x. Okay? And the right-hand side has a 6. And so now that I have one log on the right and one log on the left, I'm allowed to drop those from the problem. This is what's called one-to-one. The inside of these functions has to be equal, so I'm allowed to just set them equal without logs in my problem. Now this is a quadratic, which means set it equal to 0. Okay? And then this one factors into, it looks like x plus 6 and x minus 1. Okay? So my solutions for this one are that x is negative 6 and x is 1. Okay? But here's where we got to be careful. Extraneous solutions could also show up in log functions, and so we need to go back and see if a negative 6 or a 1 would make any of these log expressions negative. And in this case, if you notice, 1 is fine. Right? If I plug in this 1, I get a 6 here and I get a 1 there. That's good. No negative logs. But when I plug in the negative 6 in both of these, they end up being negative 1 and negative 6. That's bad. So I'm going to throw this one out and say it is an extraneous solution because you cannot take the log of a negative number. Okay? So be careful about those. Okay? So again, I'm going to jump down to 13 and then we'll do the exponential ones separate in a second. So in this one, there is no log on the right, and so instead of me trying to drop the logs by getting both sides to have logs on them, I'm just going to say in this case base exponent output. So I'm going to turn this into an exponential function and say 2x plus 7 is equal to 5 to the third power. So I'm converting it into exponential because I have a number on the right-hand side instead of having a log on the right-hand side. So if I do 5 to the third is 5 times 5 times 5, which is 125. Okay, so 2x plus 7 is 125. That means that 2x is equal to 118. And that when I divide both sides by 2, I get that x is equal to, it looks like 59, right? And so again, when I plug in a 59 here, I'm okay. That's definitely going to be positive. So I'm going to say x equals 59 is my only solution for this particular problem. Okay, so just be careful. They're handled slightly differently, but they're both different ways of solving log problems. Okay, so let's go down to number 14 now because this is still using logs, and so we'll wrap up all the log stuff, and then we'll look at this one with e separately. So problem 14, I want to, in this case, isolate the log. So if you notice in number 13, the log was the only thing on the left-hand side, and so I didn't have to really worry about trying to get that alone. It was already alone. But in this problem, the ln is not by itself. It's got a minus 3, and it's got to multiply by 4 on the outside. So my first step is add the 3 over and then divide by the 4. And so this will say the ln of x is equal to, well, that's 8 divided by 4, which is 2. Right? So now we got to remember, how do I get rid of an ln so that x will be by itself? And so what we said was the opposite of ln is e. right? So if I want to get rid of an ln, I'm going to use an e. And so what I'm going to do in this case is make e the base of both sides. So this now says e to the ln of x, and the right-hand side says e squared. E and ln cancel. That's what I want it to happen. X is by itself. And so I can go to my calculator. Let me bring that up. Right? So my calculator, I can now go to the calculator and type in, okay, e squared. So I'm going to say second ln, okay, to bring up my e to the second power. And it looks like that comes out to be about 7.4. And so I'm going to say x rounded to the nearest tenth. Oh, it says rounded to the nearest hundredth. So I'll say 7.39, okay, would be rounded to the nearest tenth. And again, I'm just going to go back and check that. If I plug that in right here, that stays positive, so I'm good. This is my answer. It is not extraneous, okay? So now let's talk about 12. 12, it follows a very similar pattern to number 14, where I'm going to say, let's get e alone. So my very first step is to divide both sides by 15, and I'm going to say e to the 2x minus 9 equals, well, 45 divided by 15 is just 3, okay? So now I'm going to do the kind of the opposite of what I did down here. In problem 14, I needed to get rid of ln, so I applied e. Well, if I want to get rid of e, I'm going to apply ln. So I'm going to say the ln of e to the 2x minus 9, right, this is all in a big parentheses, is equal to the ln of 3. Because I ln the left, I also need to ln the right, right? And so now I can say ln and e cancel. This says 2x minus 9 equals the ln of 3. And remember, at any point, you can go to your calculator and just type in the ln of 3. I'm going to wait until the end and just do it all in one shot. So I'm going to say add the 3 over and then divide by 2. This is going to become, let me get rid of this little arrow that's in our way here. Okay, I'm going to say this becomes x equals the ln of 3 plus 9, right? We add the 9 over, and then we're going to divide this whole answer by 2, and this is what I'm going to go to my calculator and type in. So again, let's come over here to the calculator, turn it back on, okay? And I'm going to say, it looks like the ln of 3, okay? And then I'm going to close my parentheses, add the 9, okay? And I'm going to hit enter, just so my calculator will complete that first part, and then I'm going to divide that answer by 2, okay, and it looks like 5.05 rounded to the nearest 100th. Okay, so 5.05. Okay, and again, if you go for exponentials, we don't have to go back and check for extraneous. That's something for logs and ln's only. So 5.05 would be my answer, rounded to the nearest 100th. Okay, problem number 15 is asking us to rewrite the following expression in completely expanded form, and what that's going to mean for us is that we don't want there to be any multiplication or division inside of a log. If there's multiplication or division, we're going to split that up, right, those factors or divisors, or up into different parts. So the first thing we're going to do is we're going to split up the numerator and denominator. There's division going on between these two expressions. When there's division going on, we're going to separate them using logs with subtraction. So I'm going to say the log base 3, okay, let me get rid of my calculator before I forget and block your screen, okay? So I'm going to say log base 3 and of just the numerator, which it looks like it says x cubed y to the 4th, okay, minus, and then I'm going to put log base 3 of the denominator, 9x, okay, right there, okay? And so now I'm going to work with each of these separately. I see multiplication between the x cubed and the y to the 4th, and so when I split these up, okay, I'm going to say each of these gets its own log, okay, with a plus sign in between them. And then I'm going to do the same thing with the second one, right? I have a 9 and an x, so I'm going to say minus. And here's where we got to be a little bit careful. I need to open up a parentheses because this minus sign applies to everything that's going to come out of this log. So when I open up a parentheses, I'm saying that this minus sign will apply to everything inside of it. So I'm going to say now the log of 9, the log base 3 of 9, okay, plus the log base 3 of x, okay? And so if you notice, now this minus sign applies to the log base 3 of 9. The log, it will also apply to this. I used a plus sign in between them because I was multiplying together the 9 and the x, and that's the appropriate sign to split up multiplication, right? I have a little bit more left to do. Here's what I have left to do now, okay? I'm going to look at this and say exponents are a type of multiplication, and so to fix that, I'm going to move those out front, right? So the 3 is going to move out front of its log, 3 log base 3 of x, okay, and then I'm going to do the same thing with the second one. It's 4 log base 3 of y minus, and then I don't have exponents in this one, but I do have something else that can be simplified. The log base 3 of 9 is 2, okay? So I can actually take this log base 3 of 9, this particular expression, and I know 3 to what power gives me 9? The answer is 2. So not log of 2, just 2, okay? And then I'm going to leave this one alone, plus the log base 3 of x. And so I can say this is a final answer. And so just to kind of give you a little bit of word of warning, it's possible that instead of having parentheses, that they might distribute this minus sign into the function and say minus 2 and minus log base 3 of x. So you might see the answer formatted slightly differently, but you should be able to identify those equivalent forms, okay? So let's do one more set of problems, and then we will end this video. So problem number 16 says, state the transformations on f of x equals log base 2 of x in order to graph this new function. So they're saying we changed this parent function into this function. What did we do, right? So the first thing I'm going to do is I'm going to say negative in front of the log. Okay, that does a reflection. Okay. And remember, an a value does a reflection over the x-axis. Okay. Let me get my letters all there. That's an E, reflection. Okay. And then I have a minus 3. A minus 3 is going to move to the right by 3, and then a plus 4 is going to move us up 4, right? So we're just identifying A, B, C, and D. Again, no B value in this problem, right? We're okay with that, okay? Problem number 17 says rewrite each function in its exponential form. So this one is just going to say 2 to the 5th power is 32. Remember, base, exponent, output. This one doesn't have an exponent, and so I'm going to put, a base. And so remember, logs without a base are log base 10, and so this one's going to say 10 squared equals 100. Okay, ln is, remember, really log base e, and so this is really going to say e to the 5th equals x. And then this last one, before we rewrite it, we need to isolate the log, and so I'm going to divide both sides by 2, turn it into log base 3 of 81 equals 4, okay? And then this actually makes no sense. Oh, no, I'm not sorry, it does. 3 to the 4th equals 81. I'm sorry. 3 to the 4th does equal 81, so it does make sense. All right, so in order for us to do a conversion, anything outside of the function needs to go away first. Okay? Problem number 18. It's saying find the value of m that makes the expression true. So we're looking at the left-hand side and the right-hand side. We're saying they are right now, this 27 to the x plus 1 is different than 3 to the 3x plus 5, and we need to create an m value so that the right-hand side and the left-hand side will be equal. Before we can do that, we need to be able to compare the left-hand side and the right-hand side. We can't do that right now because this has a 27 base, this has a 3 base. So I'm going to change the left-hand side so that it has a base of 3. So this is 3 to the 3rd times x plus 1. Okay? And then I didn't change the right-hand side at all, so I'm just going to leave that one alone. 3 to the 3x plus 5. Okay? And then I'm going to distribute this just so it looks a little nicer. 3 to the 3x plus 3 is equal to m times 3 to the 3x plus 5. Okay? So now when I compare them, it's a little bit easier to see that the only thing that's different between these two is that this one's got a plus 3 and this one's got a plus 5. They both have a 3x. They both have a base of 3. They're identical in those ways, but it looks like we need to decrease this 5 by 2 units so that it will be a 3 instead of being a 5. And so in order to do that, I need to make sure that this m has a base of 3 so that it's allowed to interact with this other part which has a base of 3. They have to have the same base or they're not going to combine at all. And then in order to decrease the exponent of plus 5, I need to go put a negative 2 here. Negative 2 plus 5 will give me a 3. Right? And so I'm going to say the answer to their question, what is the m value? Well, we just created an m value of 3 to the negative 2, okay, which we can simplify to be 1 over 3 squared, which is just 1/9. Okay? I'm not going to do letter B because letter B is, again, exactly the same as letter A. You just need to turn them both into base 4, okay? And then you can perform the same operation, pick an m value so that the left-hand side and the right-hand side will be the same.